We saw that even when a test had high specificity and a high sensitivity, if the condition being tested for had low prevalence, there were many false positives. In most situations, random testing is associated with low prevalence. But what if we only test when there's a higher chance the condition is present? For example, we administer a COVID test when someone shows COVID symptoms, or a drug test if someone shows evidence of drug use. So again, let's suppose our test is 99% sensitive and 95% specific. We can set our path diagram up as before. First, we branch into whether or not a person has the condition. Of those who have the condition, the test returns the correct result, positive 99% of the time. And of those who don't have the condition, the test returns the correct result, negative 95% of the time. But what's the prevalence? So let's consider two cases. First, suppose only 2% of those tested have COVID. We actually did this computation earlier and found, so a negative test result is almost certainly correct, while a positive test result is more likely incorrect. This doesn't mean that testing is useless. For example, even when the prevalence is low, the probability of having the condition is 2%, while the probability of having the condition given that there was a positive test result is significantly higher. So the positive test result did make us more confident that the condition was present. But suppose instead that 20% of the population tested has COVID. This time a greater fraction has COVID, and we can find out how many do and do not. And again, since our test is 99% sensitive, then we know the number who will test positive with the remaining testing negative. And we know the number who don't have COVID, and so the specificity will tell us how many of these people test negative, and the remaining people will test positive. Now, there are 2,380 positive test results, of which 1,980 are true positives and 400 are false positives. So the probability a person has the disease given that they tested positive, well, that's the fraction of true positives out of the whole, which means we're much more confident a person has COVID if they test positive. Also, note that the probability a person doesn't have COVID given that they tested negative is, so if a person tests negative, that result is still almost certainly correct. Or let's consider a third scenario where 90% of those tested have COVID. Going through our calculations, we find and now we see the probability of having the condition given that we tested positive is close to certainty, and the probability of not having the condition given that we tested negative is still pretty high. So in this case, both a positive and a negative test result are likely correct. Now, it's always worth building up some intuition, so let's do that. The positive results are either true positives or false positives. If the prevalence is low, there won't be that many true positives since most people don't have the condition. But if most people don't have the condition, there will be many false positives. So we could expect many of the positive results to be false positives. And again, if the prevalence is low, there will be many true negatives since most people don't have the condition. There are very few people who have the condition, so there will be even fewer false negatives. So in this situation, a positive result might or might not be meaningful, but a negative result likely will be. Now let's consider one more extreme case. Suppose the prevalence is very low, say 0.01%. This time we'll assume that 1 million persons take the test, and completing our path diagram we find the probability a person has COVID given they test positive is extremely unlikely. But since the probability they have COVID in the first place is also very low, note that the quotient of these two probabilities is pretty high. So a positive result means it's 20 times more likely a person has COVID. The significance of this last example is this. If the condition is rare, a positive result greatly increases the probability a person has the condition, even though the probability itself remains very low. And so it's very important to be aware that when somebody says a probability has increased by some factor, it might still be a very low probability event.